My dear students, welcome to chemistry class. This video is about structure and preparation of oxacids of phosphorus. Also, we are going to discuss about the preparation, chemical properties and uses of oxygen. So first we are going to discuss about structure of oxacids of phosphorus. Structure of oxacids of phosphorus. So the first member is hypophosphorus acid. Hypophosphorus acid. So this is the name, then formula, then structure. Okay. So the formula of hypophosphorus acid is H3PO2. Then structure is phosphorus in the middle, hydrogen, here also hydrogen, OH, then here double bond O. This is the structure of hypophosphorus acid. Second member of oxacids of phosphorus is number 2. This is orthophosphorus acid. Orthophosphorus acid. That formula is H3PO3. That structure is phosphorus in the middle, OH, here also OH, then here H, and here double bond O. This is the second structure. Then number 3, third member is hypophosphoric acid. Third member is hypophosphoric acid. Phosphoric acid. That formula is H4 P2O6, and that structure is 2 phosphorus, so phosphorus, here OH, here OH, and here also OH, here also OH, and here double bond O, here double bond O. So all the structures are very easy to draw. Just remember the formula, then the structures will be very easy. Then that fourth member is, fourth is orthophosphoric acid. Orthophosphoric acid. Formula is H3PO4, and that structure is phosphorus in the middle, then here OH, here also OH, then down also OH, then here it is double bond O. Next one, next name is pyrophosphoric acid. Number 5, that is pyrophosphoric acid. That formula is H4P2O7. Structure is phosphorus, then oxygen, then phosphorus, here OH, then this side also OH, here double bond O, here also double bond O, and bottom is OH, here also OH. So that's all about the structure of oxacids of phosphorus. There are 5 members are there in the oxacids of phosphorus. Then we studied about the name, formula and the structure. Next we are going to study about the preparation of these acids. So now the preparation of oxacids of phosphorus. Okay. Preparation of oxacids of phosphorus. I will make one small tabular column. First one is name, second one is formula, third one is oxidation state, and that fourth one is preparation. Right? That first member is hypophosphorus acid. Hypophosphorus acid. Formula is H3PO2. Oxidation state of phosphorus is +1. You can calculate. We are preparing from phosphorus, adding water. We will get hypophosphorus acid, that is H3PO2 plus phosphine. This is the byproduct. Now balance the equation. Here it will come 3, then put 6 here. That's all. Now the equation is balanced. Okay. Second one is orthophosphorus acid. Orthophosphorus acid. Formula is H3PO3. Oxidation state of phosphorus is +3. From P4O6 we are adding water. We are getting H3PO3. That's all. Okay, so from phosphorus trioxide, that's P4O6, we are adding water, we are getting H3PO3, that is orthophosphorus acid. Balance the equation, put 6 here, then put 4. Now the equation is balanced. Okay. Next one is hypophosphoric acid. Third one is hypophosphoric acid. Formula is H4P2O6. Oxidation state of phosphorus is +4. Then phosphorus plus oxygen plus water. We are getting hypophosphoric acid, that is H4P2O6. Balance the equation. Here it will come 2, then put 2 here, then here also 2, and we are getting H4P2O6. Okay. Next member is number 4, that is orthophosphoric acid. Orthophosphoric acid. This is H3PO4. here that oxidation state of phosphorus is +5. Then from phosphorus pentoxide P4O10, adding water, we are getting phosphoric acid, that is H3PO4. Now balance the equation, put 6 here, then put 4 here. Now the equation is balanced. Okay. Next member is, that is pyrophosphoric acid, number 5, that is pyrophosphoric acid. That formula is H4P2O7. Here oxidation state of phosphorus is +5. Then from orthophosphorus acid, that is H3PO3. When it decomposed, it will produce pyrophosphoric acid and water, H4P2O7 plus water. Okay, balance the equation, put 2 here. Now the equation is balanced. Okay, so that's all about the preparation of oxacids of phosphorus. So there are 5 types of oxacids of phosphorus. We studied about structure and preparations of oxacids of phosphorus. Okay. So now we are going to learn about group 16 elements. Group 16 elements. This is called oxygen group. Oxygen group. That group name is chalcogens. Okay, the group name is chalcogens. So usually here we are going to study that about oxygen. So the first member is oxygen, O2. Oxygen, actually it is the molecular formula of oxygen is O2. So that atmosphere contains 23% and water contains 83% by mass. Okay, so here oxygen, the percentage of oxygen is 23% by mass, and it is present in atmosphere, whereas oxygen present in water is 83% by mass. Usually most of the rocks contains combined oxygen. Mostly it contains oxides of rocks, combined oxygens. Okay. Now when it comes to preparation, oxygen, the preparation of oxygen is 3 types of preparation, 3 methods. First method is fractional distillation. Distillation of liquefied air. Second method is laboratory preparation. Laboratory method, here we are going to decompose hydrogen peroxide, H2O2. Third method is also decomposition of metal oxides, that is metallic oxides. Okay, so we will study about these 3 methods one by one. So preparation of oxygen. So first method is fractional distillation. Of liquefied air. So this fractional distillation of liquefied air already we studied in class 11. Actually this fractional distillation is the method of separating components using different boiling points. Okay. Second method is laboratory method. Oxygen is prepared by the decomposition of hydrogen peroxide. Okay, first is hydrogen peroxide. It is decomposed H2O2. It will be decomposed in the presence of catalyst manganese oxide or by the oxidation with potassium permanganate. So first the catalyst is manganese oxide, that is MnO2. It will decompose into H2O plus oxygen. Balance the equation, put 2 here, here also put 2. See, this is the catalyst. Okay, catalyst. When it is decomposed by manganese oxide, it will decompose into water and oxygen. Then second method is also decomposition. So the first one is decomposition of hydrogen peroxide with catalyst manganese oxide. Second one is oxidation with potassium KMnO4, potassium permanganate. See, this is the ionic equation I am going to write. First H2O2 plus MnO4. This also we studied in class 11 last year. H plus, it will produce oxygen plus water plus manganese, and 2 plus. After balancing you will get 5 here, put 2 here, then 6, then here also 5, here 8, here 2. This reaction we studied in the balancing of redox reaction by using oxidation number method and ion electron method. Okay. Now third one is thermal decomposition of metal oxides. Thermal decomposition of metallic oxides. Okay. For example, mercury oxide HgO, when it decomposed into Hg plus oxygen, balance the equation, put 2, here also put 2. Then barium oxide BaO2, then BaO plus oxygen. So 2 here, put 2 here. Then potassium chlorate KClO3, when it decomposed it will give potassium chlorate plus oxygen, balance the equation, put 3, here 2, here 2. Then potassium nitrate KNO3, then we will get KNO2 plus O2, put 2 here, here 2. See, here all we are getting oxygen as one of the product. Okay, so this is the preparation of oxygen. Okay, so there are 3 methods. First one is fractional distillation, then hydrogen peroxide first is reacting with catalyst manganese oxide, second one is oxidation with KMnO4. So we are getting oxygen is the one of the product. Here you see thermal decomposition of metal oxides, we are getting oxygen here. Okay, so next we will see about that is physical properties and the chemical properties of oxygen. So now the properties of oxygen. Properties of oxygen. So oxygen usually exists as diatomic gas. Then it is paramagnetic. Oxygen is paramagnetic. Then like fluorine, nitrogen, oxygen forms strong hydrogen bonds. Forms strong hydrogen bonds. So it forms strong hydrogen bonds like fluorine nitrogen. Okay, then allotropic form of oxygen is dioxygen, that is O2, and ozone O3, or you can say trioxygen. That symbol is O3. Okay, so it is diatomic gas, we are writing O2. Then it is paramagnetic, forms strong hydrogen bonds. Then allotropic form of oxygen is, one is dioxygen, another one is ozone, or you can say trioxygen. Okay, then this ozone, it is formed in the upper atmosphere by the action of ultraviolet rays, that is ultraviolet light. Okay, so by the action of ultraviolet light. Okay, in the lab preparation, that is ozone is prepared by passing of electric discharge through oxygen. This is the lab preparation of ozone. Okay, that potential voltage is of 20,000 volt, about 10% of. So when you pass around this 20,000 volt, so 10% of oxygen is converted to ozone, and the mixture is known as, that product is known as ozonized oxygen. Okay, ozonized oxygen. So pure ozone is obtained as pale blue gas. So that color is pale blue gas. So it is obtained by the fractional distillation of ozonized oxygen. Okay, so that equation is O2 oxygen, it will form atomic oxygen. This is oxygen, this is atomic oxygen. Then here balance 2. Then this oxygen, when it combines with atomic oxygen, we are getting ozone. Okay, then structure of ozone. That ozone molecule is bent shape and symmetrical with delocalized bonding between oxygen atom. Then symmetrical with symmetrical with delocalized bonding between oxygen atom. Okay, so now I am going to draw that resonating structure of ozone. So oxygen, this is the bend shape. Okay, then here one lone pair, then here two lone pair, here three lone pairs. Okay, now bonding will be here double bond, and here single bond, and here plus charge, and here that is minus charge. Okay, now this is the resonance structure, oxygen, oxygen. So this is ozone. Here single bond, here double bond, and here it will get plus charge, then here 2. So this will come this side. Okay, minus charge, and here 2 lone pair electrons. Okay, so that's all about ozone. So preparation, that is two types of preparations are there. It is formed in the upper atmosphere by the action of ultraviolet. Then lab preparation, you have to pass electrical discharge through oxygen at the potential voltage of 20,000 volt. So when passing this 20,000 volt, 10% of oxygen will be converted to ozone, and that produced mixture is called ozonized oxygen. So the pure ozone is pale blue gas, and it is obtained by fractional distillation of ozonized oxygen. See the equation. Then structure of ozone, this is the resonance structure of ozone. Okay, it is bend shape, and that delocalized bond you can get between the oxygen atom. Okay, next we will see chemical properties and uses of oxygen. So now the chemical properties of ozone and oxygen. Chemical properties. Oxygen and ozone. So they have many differences, and the reaction differ vastly. So oxygen combines with many metals and non-metals. So oxygen combines with metals and non-metals, form oxides. Okay, so with S block elements, so the combination of oxygen occurs at room temperature. S block with oxygen at room temperature. Okay, some less reactive elements. So less reactive metals react when it is in powder form. So less reactive metals react with oxygen in powder form. Okay, powder form. Also, so this powder form react exothermically. Powder form react exothermically with oxygen at room temperature. Okay, room temperature. So I am writing in shortcut. Okay, so less reactive metals react with oxygen in powder form. This is very important. With react exothermically means it will produce high temperatures, means it will produce heat. Okay. This finely divided powder form, it is called powder form. Powder form is known as pyrophoric. Okay, it is known as pyrophoric. Pyrophoric. Clear? Now we are going to learn about ozone, the chemical properties of ozone. Ozone, actually, it is a powerful oxidizing agent. Powerful oxidizing agent, and it reacts with many substances under conditions where oxygen will not react. Okay, so it reacts where oxygen does not react with that substance, with many substances. Okay, so oxygen, compare with oxygen, ozone is highly reactive, so it can react many substances where oxygen does not give reactions. So for example, it oxidizes potassium iodide, oxidizes, example we can say, oxidizes potassium iodide to iodine. So the reaction, it is used to estimate the ozone. So this reaction used for the estimation of ozone. Okay. So the reaction is ozone plus potassium iodide, H2O, we are getting oxygen plus iodine. Okay. So balance the equation, put 2 here, then put 2 here. So that's all. This reaction is balanced. Okay. So oxidizes potassium iodide to iodine. So this reaction is mainly used to estimation of ozone. Okay. And uses of ozone we are going to see. So now the uses of oxygen and ozone. Uses of ozone we will see first. So the main use of ozone is oxidation of organic compounds. Also, in acidic solution, ozone exceeds the power of, so it exceeds the power of oxidizing power. Okay, oxidizing power of fluorine and atomic oxygen. Okay, so oxidation of organic compounds, that is one of the most important use of ozone. Then it is a highly oxidizing reagent, so it exceeds the oxidizing power of fluorine and atomic oxygen. Okay, the rate of decomposition, of ozone drops in alkaline solution. Okay, so that's all about ozone. Now we will see the uses of oxygen. Now uses of oxygen. So there are 3 important uses. It is the essential component for survival of living things. Living organism. Second one, it is used in welding. That is called oxyacetylene welding. Oxyacetylene welding. Okay. Third use, important use, that is it is used as a fuel in rockets, etc. Okay. So that's all about oxygen. So today we learned about structure and preparation of oxacids of phosphorus. Also we studied the preparation properties of oxygen and ozone and uses of oxygen and uses of ozone. Okay. So in the next video we will discuss about sulfur, that is the another element of 16th group. Okay students. So thank you very much.